Need stuff. All right, math 35, no, 335, that's what we're doing, right? 335. And we got thrown off a day, so this is day 8, not day 9. Day 8, or day 6 of lecture. And we were doing, the harder thing we were doing were binomials. That was like a big thing. Binomial factoring was what we were covering the most last time. So let's take a look at that. Recall we were using a squared minus b squared was a minus b, a plus b. And you could do it in the other order. You could do a plus b and a minus b. The more you write this formula down, the generic form, eventually you stop needing to write it down. Holds true with the cubics as well. The more you write down a cubed minus b cubed equals a minus b, a squared plus ab plus b squared. And then a cubed plus b cubed. The first two signs flip. So those impact those two signs, and that's the only difference between those two formulas. When we start doing, when we start having complex numbers, we will see that a squared plus b squared factors later when we do complex numbers. But that's for later. So that's just a reminder of the formulas. So all of these are going to be factored. Let's do 81 minus 9y to the fourth. Oh, this is a better one. Well, let's just do 81 minus y to the fourth, no 9. Won't put the 9 there. 81 minus y to the fourth. Go ahead and factor that. See what you come up with. Are you done?
Getting there, I think.
Hey,
Yes.
where did you get your?
Very big ones, kind of chosen the.
What did you get? Yeah, I'm gonna give Eric a chance to catch up and work on it. Might as well. I don't mind sitting here slumming it, kicking back. Not slumming it, but you know what I mean. Feel free to discuss it with each other. So which of these formulas is going to apply? So make sure you guys are looking at the right thing.
Isn't it like no, is it substitution or basically the 81? You can do the is it 9 squared. Squared is it's be y squared. Y squared and then all that squared.
Yeah,
Yeah.
so
Sum of cubes, right?
these are squares,
Oh, squared, I mean.
difference of squares.
Gotcha. This is pretty close.
So the squares comes off of them having exponent 2 outside. Difference is the result of subtraction. When we do addition, it's sum. So sum of cubes, difference of cubes, difference of squares. So we've got 9 minus y squared, 9 plus y squared. We are not done. How you doing, Luis? This is a sneaky one. There's more that factors here.
There is.
Which one of those factors and which one doesn't? They both have a 9. That doesn't help. Say it again, Drew?
They both factor.
No,
No.
not yet. This has got a plus. This will factor later. But the first one is actually 2 different things squared. 9 minus y squared is 3 squared minus y squared.
Squared.
So that one breaks down more also. Look at this sneaky sons of bitch. So we have a 9 plus y squared, that doesn't factor yet. And the 9 minus y squared can turn into 3 plus y and 3 minus y. That's where it stops. So to figure out which one you're doing, it helps to look at the variable exponent. When there's only 2 terms. If it's the exponent is divisible by 2. Then it's going to be difference of squares at most. If the exponent is divisible by 3. This will be sum or difference of squares depending on the sign. If anything, or not squares, cubes. It may not factor. One of them may not be a cube, so you may not be able to do anything with it. If the exponent is divisible by 6, both work. Well, I'm about to show you this one. This is the magic one. This just might be the extra credit problem on the midterm. What I'm about to do. So we'll work it out together and determine which way is the best way.
What's it say right there? look at variable exponent and there is. Right,
To look at variable exponent when there's. Only, it should say only two terms. Okay, you guys ready to see the math? Let's do the 6 power minus. Which is the same as x to the 6th power minus 1 to the 6th power. Because 1 to any power is still 1. So 6 is divisible by both 2 and 6 is divisible by 3. So which order do we go in?
largest rate. It's divisible by 3, so we use the sum of.
We can use squares or cubes here. And we're gonna probably have to do both. So let's say we start with a big. This would be, let's do the cube one. So this is x squared cubed minus 1 squared cubed. So we put that in the pattern. The pattern is a for a cubed minus b cubed. We've got a minus b, a squared plus ab plus b squared. That's my a and that's my b. So I have x squared minus 1, that's a minus b. And then x squared squared. Plus AB is plus x squared. Plus b squared is 1 squared squared. So if I clean it up a little bit, we have x to the 4th plus x squared plus 1. And this first one is difference of squares, right? So that could be x minus 1 and x plus 1. And the other one is x to the 4th plus x squared plus 1. And I'm not sure how to factor that anymore, so I'm going to stop. Let's do it where we do the square formula first, which means writing this as x cubed squared minus 1 cubed squared. So here we're doing a minus b, a plus b. Go ahead and work that out, see how you do. What are you guys doing so far?
X cubed minus one. Times X cubed plus.
That's correct. That's our first step. We did the squares, now we gotta look for the cubes. And these both have cube formulas. So we'll have those, we got the. This is the a cubed minus b cubed up here. And as a reminder, so that's a squared minus b squared there. A cubed plus b cubed is a plus b. A squared minus ab plus b squared. So now apply that and that to that and that. Oh, it breaks down more. They both factor. What is this bullshit? The fuck is this villain shit, Drew? Doing this shit. You're about to do it too. That's some fucking villain move right there. Stroke the beard.
But like, so when you say. Okay, that one would be A and that one would be B, correct? That term X cubed minus one.
Well, this will be the a cubed minus b cubed one. And this will be the a cubed plus b cubed one.
Okay.
See it? Cause I can put a one, make this one cubed on both of them.
Thanks.
So it's a twofer. Gives you all sorts of practice on binomials, right? I guess done. You might find it easier to break them up, do them one at a time, and then reassemble the shit afterwards. Just focus on the x cubed minus 1 first. So A is x here. And B equals 1 from below. So we're just gonna follow that pattern. And replace all the A's with X's. And replace all the B's with 1's. So that looks like x minus 1, x squared plus x plus 1. That's the x cubed minus 1. And then when we do the positive one, well, we can follow this pattern, still A equals x and B equals 1. And we can follow it, or we can recognize that these are identical and we're using the same things, A equals x, B equals 1. So the only difference should be these two signs right here. This should be plus 1, and this should be minus, not minus 1, minus x. Does that match up with like that? X plus 1, and then A is x squared, minus A times B, minus x times 1 is just minus x. And then plus 1 squared is just plus 1. So we can put this all together and say x to the 6th minus 1 factors into, I'll do the little ones first, x minus 1 and x plus 1. And then we had x squared plus x plus 1 and x squared minus x plus 1. So this is pretty tricky. I see these down here, which means this must factor to this. It must factor to that. But we don't have any tools for doing it. So the big takeaway on this, and this is probably the only one you'll ever really see it happen on, other than maybe if this is a 2. Like 2 to the 6th power is 64. So if you had x to the 6 minus 64, that's doable. 3 to the 6th power, you're starting to get really fucking large, and no one's gonna recognize that one. If both exponents are divisible by 6, start with A. I'll use A's on both of them, or A and B. The best way strategy here was starting with doing the squared thing. A cubed minus B cubed times A cubed plus B cubed. Which is starting with difference of squares. You'll be able to factor further easier. It's about 4 o'clock, so it's not recording.